How you guys doing? Randy Richard here in the shop, and I want to do a little intro for a friend of mine. He's actually a gardener and landscaping expert. He's a master gardener, and he's going to start doing YouTube videos in the area of gardening and landscaping. And as you saw on the back of my shirt, this is his T-shirt. The Lazy Landscaper. His name's Ed Dunn, and I'm going to put his link up to his YouTube channel. He just got one video up, his intro, and he's got a whole bunch more he's going to be putting up. They're short, but if you're into the gardening and landscaping interest, he's very good. I think he'll probably be kind of a funny kind of guy in his videos, but we'll see how that goes. But give him a shot if you're interested in that stuff, and just want to give him a shout out. And he's going to be selling his t-shirts even, from what I understand. So, but I'll put up his link to his email and his YouTube channel. So good luck, Ed, and hope to see some more of your videos. And we're gonna probably also try to work out so we could do some projects together, some maybe some woodworking stuff for the garden, or even some metalworking stuff for the garden. So we'll see how that goes. So anyway, in this video, we'll move on here. This video is going to be about a part I introduced in a weekly catch-up a little bit back, and for a viewer. It's a locking mechanism for his Tablesaw fence that broke. So I'm just going to make him a whole new one. It's really not worth repairing. The type of metal he used, it was probably offshore brand. I'm not sure on that, but it's identical to my Delta Unisaw fence, a locking mechanism. And I'm going to show you that. And so we actually have a model for one that's not broken, but it's identical. And where it's going to be a quick project. And we'll just get her done and get it back to the viewer for him. So let's swing around. Let's take a look at things. Thanks a lot, you guys. Now this is the Unifence on a Delta Unisaw. This is mine. And I'm going to turn this over here and show you the part we need to make. This is identical to the broken part that viewer Ben sent. It's the silver part here, right there. It's on there with a roll pin. Here's the broken part. And this actually came off of a Delta Unisaw. Also, his. Got closed. The garage door closed down on it somehow, so it broke this piece. So you can see how it has a 1/4 inch hole it's not in the center, and then a 3/8 groove that's all the way through, or slot, and it goes right on there like that. There we go. So at least I have one to measure off of to make the drawing from. Get a little close up here of it, how it goes on there. Like I said, it's just a 1/4 inch roll pin holding it on there. And it turns like that so you can slip it out of the rail. Anywhere along the rail you can remove the fence. So here I'm going to make the drawing. This is sped up just a little bit to facilitate things here. It took me about 15 minutes to make the drawing, that's all. So we cut it down to just a few minutes here. Now I'm using AutoCAD Inventor, and I'm using a free online screen capture program called Screencast-O-Matic. You can see that it has a logo down there. Actually works pretty good. I might just have to buy this program. It actually works pretty well. So you guys can let me know what you think of this. It's kind of neat to be able to screen capture
to making drawings and stuff. It's kind of neat. So we're drawing I drew the making a 2D sketch here, and then we'll turn it into a 3D. So I drew the rectangular outline first. Now I'm drawing the slot, 3/8 wide by about an inch long. And we're able to, specify all the dimensions here as we go, and trim it. Boom. Now we have a slot. Now we need to draw the angle cuts on the end. Specify the location which I measured and the angle. Now, this is the most critical part. Is probably the last hole we have to put in, get it offset, and the slot is pretty critical. But the rest of the dimensions, if you were within 5,000, you're going to be probably fine. It's not that kind of a tolerant fit for this piece. Now, a few of these things here, I drew this in the wrong. I drew some of these things kind of like off to show how easy it is to edit or change something. And so this one's obviously not in the right place. So we need to make it. We can either drag it into the right spot, or I can actually put a constraint, which would be a dimension. I can dimension that out and then just type in the actual dimension it needs to be, and that will correct. There, I was off. I need to be a little bit different than that, a little shorter, since I can't type. So, and then we just can trim off the pieces we need. Like this is just a two-dimensional sketch right now, and of the side profile. Yeah, it looks good. Still trimming here. There we go. And now we'll extrude it to the 5/8. It's a 5/8 square stock, so 5/8 thick, and there's basically the part. Now we need to put in the 1/4-inch hole, and how you can select your faces of what to draw. And there's the face I want to draw on, and we need to pop in a 1/4-inch hole. Now I do put it in the wrong location because of a simple. I did not put in that it was minus the Y position. I put it in as positive, so that's wrong. And I'll now correct that real quick. Put it in minus, and it will just go right there. There we go. Then you can delete the other one. Oops. Now we have the right. Now we need to make it a hole, extrude it through the piece as a cutout, and there, our part's done. Now I could also draw in chamfers and I mean all that, but there's no need for this part to do all that. We're just going to clean up the edges on a Scotch-Brite wheel. Now that was the three-dimensional drawing. Now we're going to make a schematic here. Isometric drawing. I can't remember. I can't remember all this stuff. Anyway, a drawing on a piece of paper, so two-dimensional that we can see, and with some 3D pictures even. And we'll dimension it out. Put in some tolerances there, or how far, how many decimal places do you want it to be? I usually just do things to three places, sometimes even less on things, but usually I always do things to 3 places, thousands. Pretty easy to do, just go along. Select the points. Now I have the program to ask me each time what I want each dimension. To me, it makes it a little easier. Yeah, I have to do some extra clicking, but that way I can decide on each dimension how do I want it to be. Nice thing about this too, you can select if it's a threaded hole. You can say, "Oh, give me the specifications on that threaded hole," and it automatically put it on there for you if you drew it as a threaded hole. tap drill size, the thread, all that stuff. There we go. I think we're done. I don't know what I was going. I was going to move that dimension. Yeah, there you go. And then came out pretty good. And then I can print that out. Now I also drew this. Here's the stock 5/8 square cold roll. There's a broken part. There's my little angle plate I'll use to do this first setup for the angle. Here's the. I also drew this in AutoCAD Lite as a two-dimensional. I drew this. It probably didn't even take me 5 minutes, maybe 10 minutes at the most there to draw that. So then I went over to AutoCAD Inventor and drew the three-dimensional drawing. I really like AutoCAD Inventor. I've used AutoCAD a long time, so I'm pretty used to the AutoCAD's kind of stuff. I don't have SolidWorks. I can't afford that. So I go with some stuff that I can get for basically free. Needs to be 4 1/4, so I'm going to mark this off, leaving a little. That way I know where my lines are, so I have a little extra room to mill off the ends nice and square. I'm just going to take it over to bandsaw and cut it off. So we're in the mill. Going to clean up one end, then we'll flip it over, clean it up, measure it, and trim it to 4 1/4 inches. There's a 3/4 inch high speed steel, 2 flute end mill. Actually, the end of it's kind of got buggered up a bit, so I'm just using the side of it. It's still nice and sharp. Now I give this a measurement. I get a measurement now. It's cleaned up. I punch that number into the VRO and know exactly how much I need to go over for 4 1/4 inches. Makes it a pretty slick feature, just be able to punch that number in and know how much you got to take off. Came out right on the money at 4 1/4 even. Final measure, check. Now I use my 20-degree angle block. I'll set it in there against the mill stop that's on the vise, and that's our 1 1/4 mark from the end. That will just mill to. Yeah, like I said, these aren't need to be super precision. Angle of it is probably more important than about how much. That just gives you the turning, so it can turn in the slot in the rail for locking. Now I'm using a carbide inserted M-mill face mill 3 insert cutter. Picked up at Inco during one of the sales. This is actually the first time I've used it. It worked extremely well. I was very, very happy with this. Takes my triangular inserts. There's one end done. Now I just put this on a parallel to get it up to a height I can mill the other end, and backed it up against that stop there on the end of the vise, and was able to mill it down to the mark, same as the other end. I was taking 40 and 50 thousandths cuts, except for the final was like about 10. So that came out really nice. A really nice finish on there. I was very, very pleased with the miller, with the cutter. There it is. It's 1.5 inches in diameter. So now we're going to set up for the slots. So I'm only going to put the parallel in each end in about 1.25 inches to set the piece on, so that they won't be in the way when I mill this out. There's not much room on the sides, about 1/8 of an inch, so it's pretty pretty thin on the sides after you mill that out. It's 3/8 of an inch slot. So I only put them in a little ways, on one on each end, and give it some taps to have it down tight. And that worked out real well. I need to move it over a little bit so I get in there. But having the parallels just barely in there worked out good. I'm using a little anchor lube that's thinned out here to drill. I'm going to drill a 3/8 hole on each end and one in the middle, and then mill it. Now, using a drill is the most efficient way of removing metal and makes the milling go a little quicker. So I cleaned this slot up with about, I think it was three passes in there, and I had the ends marked on the DRO, so I was able to use the DRO to know just how far I was going there to the ends. I used a high-speed steel 4-flute cutter there. Now we need to turn it 90 degrees, and we'll, after I deburr it there, we'll turn it, put the 1/4 inch hole in. It's off center by about 1/8 of an inch and a 1/4 inch hole, and it's centered to the length. There we go. We'll deburr, and part's done. Should work great.
Here you go, Ben. Part's all done. Looks good. Matches up pretty good there. So we'll be should fit right on. Go right on there for you. I even have a new roll pin to just grind this off to the length you need, and you'll be set. Should work out fine. Another project done. We'll knock that off the list. In the mail to you real soon, Ben.